welcome back. Today we're going to go over an application of differentiation, which is in fact analyzing the graph of a function. In particular, this is a transcendental function. So in the question statement, it's asking us to sketch the graph of the function, and we need to find any intercepts, relative extrema, points of inflection, and asymptotes. So in fact, we have a good guidelines for analyzing the graph of a function. First, we're going to find the domain and range of the function. Next, we're going to determine the intercepts, asymptotes, and symmetry of the graph. And finally, we're going to check f prime and f double prime to get the relative extrema and the inflection points. And the first thing is the domain. All right, to find the domain of this function, we got to remember that the ln function, the logarithmic functions, are defined for strictly positive inputs. So this says that x minus 1 cannot be 0, cannot be negative, but it got to be positive. So that implies that x is strictly bigger than 1, and this makes up our domain, which is 1, x, and infinity. Okay, x is not even allowed to be 1 at all. And the range of this function consists of the values that y can attain. And it's sort of like harder to see from here because when x is greater than 1, okay, we know that x minus 1 is positive here. But ln of x minus 1 may not be positive till x hits 2. So in between 1 and 2, ln takes the negative values. And this is still positive. Positive times negative is going to be negative. But soon after x hits 2 and then go beyond that, so ln takes the positive values together with x minus 1. And in fact, ln goes to infinity as x approaches infinity. So we know that this function takes the values anything and everything in between 0 and infinity, but we don't know how big or how small those negative values are. I'm going to leave this part a little bit open here, but soon after we have the relative minimum found, then we're going to see what that lower value could be, because as is, it's really hard to say something about the range of this function without graphing it. In fact, you can try finding the inverse of that and check the domain of the inverse function, but that is also an extra heavy work for you. So I'm going to leave it open, but I know that the range contains the interval 0 and infinity, but we just don't know if there's anything else we can add here, because f also takes the negative values, but we don't know the minimum of those values. And the next thing here is finding the x-intercepts. Okay, so all we're going to do is to set this equation to 0 and solve for x. Well, first of all, there are two cases. One is the one that makes this 0, and the other one is the one that makes this function 0. As you see that x minus 1 is 0 at x equals 1, which is not in the domain. So in other words, this cannot be our x-intercept, because again, at x equals 1, you get ln 0, which is undefined. And for this one, ln of x minus 1 equals 0. If you take to the if you look at the e to the ln x minus 1 e to the 0, you can just see that this is x minus 1, e to the 0 is 1, so x equals 2. For x equals 2, the function takes the value of 0, and this is the only x-intercept. And how about the y-intercept? Well, y-intercept is found by plugging in 0 for x, but that gives us, so in other words, y of 0 is equal to -1 ln of -1, which is undefined because ln -1 is undefined. So there is no y-intercept. No y-intercept. All right, for symmetries, we can take a look at x-axis and y-axis and origin type symmetries. And for this one, we are gonna assign x for x and y for -y, and we have x replaced by -x and y replaced by y. And then for this one, x is replaced by negative x, and y is replaced by negative y. And check if we can preserve the form of this equation. Well, as you see that for the first one, minus y equals x minus 1 ln x minus 1. This is obviously not equal to this function because these are two different functions. In fact, the left-hand side is different from the right. The left-hand side is not the same as the left-hand side here. However, the right-hand sides are equal. So there's no x-axis symmetry. Let's check x equals negative x and y equals y. And in fact, this function has nothing to do with the function that we start with. And same as for this one, a minus y equals minus x minus 1 ln of minus x minus 1. You can even cancel out the minuses here. So you have x plus 1 ln of negative x negative 1. But again, this has nothing to do with the original function. So we're talking about no symmetry with respect to x-axis, y-axis, nor the origin. And finally, for the first set of tasks in the guidelines, we're going to look at the vertical asymptotes or horizontal asymptotes. So for that purpose, why don't we first look at the function's behavior as x goes to infinity. Okay, because the domain starts from 1, so we can't really check anything like limit as x approaches minus infinity, because minus infinity is not in the domain, or negative values are not in the domain. So as I said here, as we mentioned earlier, so if x gets large and large, this is going to be very large, so this is going to go to infinity, as well as this term is going to go to infinity. So we can immediately conclude that this is getting bigger without a bound. So this limit is going to be infinity. So in other words, there is no horizontal asymptotes. Let's check if we have anything at x equals 1, but we should approach that by, we should approach 1 from the right. So x minus 1 ln of x minus 1. And for this one, we can't really see exactly what's going on because when you are on the right of 1, so this becomes ln of something very small but positive, and then this one is 0. We were talking about 0 times negative infinity, and there's not much algebra you can apply here. So if I were you, I would just take my calculator and choose x values to be, let's say, 0.1, 0.01, 0.001, 0.0001, and see what the corresponding y's are. And I can tell you that if you use your calculator, you will see that this number goes to 0. So you're getting closer and closer to 0 as you get closer and closer to 1 from the right of 1. Okay? So this tells us that at least at 1, the function values approach 0, and apparently there is no vertical or horizontal asymptotes. For us to have a vertical asymptote, we should have checked this limit because that's the only problem point. Well, that doesn't provide us any kind of asymptotes. We conclude that the function just approaches 0 on the left end of the domain, and on the right of the domain, the function approaches infinity. All right, finally we check f prime and f double prime. Well, we have the product of two functions. Why don't we use the product rule? So it is essentially take the derivative of the first function, multiply it by the second function, and then keep the first function and multiply by the second function's derivative. And we can just go ahead and use the differentiation rules. Well, let me just continue from here. So x minus 1 has a derivative 1, so 1 times ln x minus 1 is ln x minus 1. And then x minus 1 here and times the derivative of ln of x minus 1. Well, from the differentiation rules, we know that it's the derivative of the inside of ln, which is the derivative of x minus 1, which is 1, over the inside x minus 1. Okay. Well, x minus 1 and x minus 1, they're the same, so they cancel out. So you have ln x minus 1 plus 1. And the second derivative is going to be the derivative of this function. Well, we just found the derivative of ln of x minus 1 to be 1 over x minus 1. And the derivative of 1 is just 0, so f double prime is just 1 over x minus 1. All right, let's go ahead and find the critical points. Well, within the domain of the function, there's no x that makes f prime undefined. So for that reason, we just pass that. And we're solving ln x minus 1 plus 1 equals 0 to find the other kind of critical points. So ln of x minus 1 equals -1. We're solving a logarithmic equation with base ln with base e. So here we go. So this is equal to, or this is equivalent to saying that x minus 1 equals e to the minus 1. Okay, so here x becomes 1 plus e to the minus 1, which is 1 over e. This is the only critical point. The next thing to check is the inflection points. While inflection points are the points that make f double prime either 0 or undefined. Well, there's nothing to make this function 0. There's no x. But there's a value of x that makes this function undefined, which is 1. But unfortunately, 1 is not in the domain, so we can go ahead and then conclude that there is no inflection point for the graph of y. All right, the setup table for this problem is slightly easier because we have only one critical point. And here's the domain 1 to infinity. All right, my sample points are 1 plus 1 over 2e and 3 in the subinterval. And I checked the sign of f prime and f double prime at the sample points. And I got negative, positive, positive, and positive here. So at this moment, if you have a calculator with you, why don't you have your calculator ready and convince yourself that we have minus, plus, plus, plus here. And by using the test for increasing and decreasing behavior, we have minus sign here, so f is decreasing and f is increasing here. And because of the concavity test, and here we have a plus sign, we have concave upward, and we have another plus sign, we have concave upward going on here. All right, as you see, there's no inflection point because there's no way the concavity changes. So no inflection point, but as you see that I have concave up and decreasing, so I have this kind of graph here. Up and decreasing, and up and increasing. This is the other side of other branch of the concave up. So this critical point produces a relative minimum value because it's decreasing all the way and makes a minimum, and then it goes back up, increasing. So we should observe that 1 plus 1 over e produces a relative extrema. There is no horizontal asymptote, there's no slanted asymptote, we don't have any vertical asymptote. Why don't we get a visual of the graph of the function and try to match it with our findings here? And here we go. So here's the graph of x minus 1, ln x minus 1. As you see, 0 is not in the domain, so I put a hole here. But we know that the limit approaches 0, okay? So the behavior of the function here is concave upward but decreasing. And I should have a minimum at the point 1 plus 1 over e. Here we go. I have a relative minimum value at this point. And then the behavior of the function is concave up and increasing here. So as you see, it's increasing all the way, but there's no slanted or vertical asymptote. All right, our table is verified, and this makes the end of the video. Thanks for watching. I'll see you in another video. Bye.